Hello friends, I welcome you all on this YouTube channel. Most welcome. So this question is straightforward formula based question. This question has already been asked in your EAC 2008 examination. The question statement is like the daily energy produced in a thermal power station is 720 megawatt hour at a load factor of 0.6. Then what is the maximum demand on the thermal power station? So here the daily energy produced is given as 720 megawatt hour, load factor is given as 0.6, and you will have to then calculate the maximum demand on the thermal power station. So you know that the load curves, they are plotted either on daily basis or on monthly basis or on yearly basis, right? So load curve basically tells us the variation of the load with respect to time. So load curves helps in determining the maximum demand on the power station. Alright. So maximum demand for different consumers is different and occurs at a different time, right? So load curves helps in determining the maximum demand on the power station, and maximum demand helps in deciding the ratings of the power station equipments. Alright. So here load factor is nothing but the average demand by the maximum demand, right? So load factor means basically how much is the average demand with respect to the maximum demand. That is a load factor, right? So either you can say average demand or you can say average load. Both are one and the same. Similarly, maximum demand is same as maximum load, right? So like I said, maximum demand for different consumer is different and occurs at a different time. So here first you will have to calculate the average demand, right? So average demand, how to calculate? He has given the daily energy produced 720 megawatt hour. So for daily energy produced 720 megawatt hour, for that is a daily energy produced, you first divide it by 24 hour. That is basically total number of hours in a day, right? So in one day we have 24 hour, right? So divided by 24, so 720 divided by 24, 30 megawatt, and then maximum demand, it comes out to be equal to average demand by load factor. So from here you write 30 megawatt, that is the average demand, and divided by load factor, that is 0.6, it is given, right? Load factor is given 0.6. So here the maximum demand comes out to be equal to 50. Maximum demand comes out to be 50 megawatts, and that is the answer. Now had it been the monthly load curve, right, then you would have been divided by 20, the total number of hours in a month, right, instead of 24, right? So since in the question it is a daily load curve, so you have divided it by 24 hours. That is the number of hours in a day, in a single day, right? So had it been the monthly load curve, then you would have divided it by total number of hours in a month. And had it been the yearly load curve, then you would have been divided it by total number of hours in a year, right? And likewise, right? So for the daily load curve, you will have to, for the calculation of average demand, you will have to divide it by simply total number of hours in a day, that is 24. So 720 by 24 is 30 megawatt, that is the average demand or average load. So likewise, you can calculate the maximum demand on the power station. So 50 megawatt is the answer. Thank you very much. Thanks for watching. For all such kind of exam oriented questions, please subscribe to this channel.